Okay, and here we are with the last lecture for Chapter 20, Enzymes and Vitamins. I guess I don't have to tell you all that this will be our vitamin lecture. You've done very well, I hope, with understanding all the enzyme content presented, and now it's time to turn to those all-important vitamins. So as you can see, this lecture will not only focus on the vitamins, but also enzyme cofactors, which may or may not be vitamin in nature. So let's take a look at enzyme cofactors. A simple enzyme is an active enzyme that consists only of protein. Many enzymes, in fact, are active only when they combine with cofactors. And these cofactors can be metal ions, which would not be vitamins, or they can be small molecules, which, as we see, coenzyme is a cofactor that's a small organic molecule, such as a vitamin. So these cofactors may be vitamins, or they may be metal ions. They're just necessary in order for the enzyme to become active. Let's address the metal ions first. So the metal ions are not vitamins, they're minerals. Metal ions themselves, like zinc, might be used. Zinc, for instance, zinc 2+ is a cofactor for carboxypeptidase, and its function there is to stabilize the carbonyl oxygen during the hydrolysis of a peptide bond. So we see the active site there of the enzyme. It has a nice place for the histidine residues along with a gluconate residue, stabilize the zinc ion, coordinate it with those lone pairs on the nitrogens and oxygen, and then that zinc in turn can be stabilizing the carbonyl oxygen, the lone pair on the carbonyl oxygen of the amide rather, or peptide bond, in order to allow hydrolysis to occur in the enzyme. So without that zinc 2+ ion, we don't get function out of that carboxypeptidase A enzyme. Here we see a table of some other enzymes and their cofactors. So table 20.8 shows us enzymes and the metal ions required as cofactors. So you can see there we've got copper 2+ and copper 1+ for cytochrome oxidase. So we have the copper changing oxidation state as part of the oxidation reduction process that the cytochrome oxidase catalyzes. We also have an iron 2+, iron 3+ metal ion involved in catalase cytochrome oxidase. And then as we see that zinc 2+, we just talked about it with carboxypeptidase A. It's also involved in carbonic anhydrase, a very important enzyme that helps to stabilize carbon dioxide and water. And then alcohol dehydrogenase, another zinc-containing enzyme. Magnesium 2+ is important for glucose 6-phosphatase hexokinase, and we have manganese 2+ for arginase and nickel 2+ for urease. So there you see a number of metal ions which we need in very, very small amounts in order to make these enzymes active. So now on to the vitamins. Vitamins themselves are organic molecules that are essential for normal health and growth. They're required, like those metal ions that we just mentioned, in only trace amounts, so very small amounts of these vitamins. They do need to be obtained by the diet. We cannot synthesize these. We have to obtain them from dietary sources, and they're grouped into water-soluble vitamins and then fat-soluble vitamins. So we'll take a look at each of these groupings, starting with the water-soluble first. The water-soluble vitamins are soluble in aqueous solutions, just like their name suggests. They're cofactors for many enzymes, and they're not stored in the body because they're water-soluble. The excess that you might have would leave the body in the urine. And so vitamin C, for instance, is a popular vitamin that people take as a supplement. It's believed to help with immune system function, and people take it in order to prevent illness, common cold in particular. And you can take large amounts of that vitamin without much concern because you'll be excreting out the excess. Actually, vitamin C in particular, if you take too much in addition to leaving in the urine, it can cause diarrhea. So there's bowel tolerance for that one. Most people, if they take much more than a gram of it, it causes, in addition to exiting the body through the urine, it'll also likely cause some diarrhea for individuals who take far too much of the vitamin C in a short time. So here we see a cartoon showing that function of coenzymes. So a coenzyme prepares the active site for catalytic activity. So you see our active site initially at the extreme left doesn't really look ready for the substrate. Once the coenzyme fits into the left-hand side of that active site, now it looks much better in terms of that lock and key type model, able to accept the substrate and then release those products after the substrate has been acted on, catalyzed to undergo whatever reaction that particular enzyme catalyzes. So there we have it. Then the products leave and we can accept more substrate. Without the coenzyme, we don't have an active enzyme because the substrate itself doesn't complete that active site. So that's why these coenzymes are so critical, because the enzyme itself can't function without them. Here we have table 20.9, a description of some water-soluble coenzymes, vitamins, and then their effect, sources, things like that. So I won't read the whole table to you. Hopefully you'll be interested enough to look these things over yourself. But we have, toward the bottom, we have vitamin C there, ascorbic acid, and its a transfer function involves electrons. Then lots of great natural sources that can provide that necessary vitamin. If you don't get enough of it, you've got some unfortunate consequences here, in particular scurvy. So bleeding gums, weakened connective tissues, slow healing wounds, anemia, and this was a scourge of the sailors in the old days when they didn't have access to these fresh fruits and vegetables that we see as the main sources, and so they would unfortunately end up with scurvy as a result of being on the seas without access to these fresh fruits and vegetables that would provide that necessary vitamin C. Fortunately, nowadays that's not such an issue, because citrus fruits in particular have a good deal of vitamin C, and they can be transported readily and consumed daily if necessary, or supplements, of course, for any of these vitamins are available in grocery stores, pharmacies, health food stores, so on and so forth. Okay, why don't we pause here for a learning check. In this learning check, you're asked to identify each enzyme as either 1, a simple enzyme, or 2, an enzyme that required a cofactor. So we've got 3 descriptions here, A, B, and C, and if you can go ahead and read those and decide whether the description is talking about 1, a simple enzyme, or 2, an enzyme that required a cofactor, make your determination, stop the video while you do that, and then start us back up when you're ready to check your work. Good luck. Okay, so hopefully you arrived at these same results. For A, requires magnesium 2+ for hydrolysis of phosphate esters. Well, that certainly sounds like number 2, an enzyme that required a cofactor. In this case, a metal ion as a cofactor, not a vitamin. So that's 2 for A. For B, requires vitamin B3 to transfer an acetyl group, and that is again, an enzyme that required a cofactor, so it should also be 2. This time it was a vitamin. And finally, in C, is active with 4 polypeptide subunits, mentions nothing about small organic molecules like vitamins or metal ions here, so this sounds like 1, a simple enzyme. So hopefully you had those all correct. If not, hopefully you understand now why those answers are correct. But if that's not the case, it's still finding some frustration with you and you're not sure why, please do reach out for some help. Okay, taking some time to look at a few select vitamins in particular. We have thiamine, which is vitamin B1, and thiamine is part of the coenzyme thiamine pyrophosphate, TPP. It's found in the liver, yeast, whole grain bread. These are the sources, so if you eat animal livers, yeast for whole grain bread, you're going to be able to take on sufficient thiamine for your own bodily needs. If you're not consuming enough in your diet or through supplements, deficiencies can lead to beriberi, and so there we see the structure of our vitamin B1 thiamine. It's typically added to white flour, if you look at the list of so-called enriched flour, because they've taken away all the good stuff from the whole grain and then have to add some back in as vitamins. The B vitamins are typically in daily multivitamins or B complex vitamins if you're taking a supplement instead of relying only on diet. Moving along to riboflavin, vitamin B2. That one's found in the coenzymes flavin adenine dinucleotide, FAD, and flavin mononucleotide, FMN. Sources of it in the diet include beef, liver, chicken, eggs, and dairy foods, as well as, of course, supplements. Deficiencies here would lead to dermatitis as the major illness associated with riboflavin deficiency. Moving in order, the next vitamin is niacin, or vitamin B3, and it's part of the coenzyme nicotinamide adenine dinucleotide, NAD+, which is involved in oxidation reduction reactions. I think when we had our alcohol dehydrogenase a few lectures back, we saw that this NAD+ was involved there, for instance. It's found in chicken, beef, fish, animal meat sources. Deficiency here can result in dermatitis, like we saw for the B2, muscle fatigue, and loss of appetite. So obviously important. What I haven't mentioned, of course, is in particular the elderly, pregnant females, young children. If it's not clear that they're getting what they need from dietary sources, certainly a vitamin, daily vitamin supplement is typically prescribed so that sufficient amounts, particularly the water solubles like the B vitamins and vitamin C, you can't really overdose on, so they're typically prescribed for those populations just to ensure that sufficient vitamins are present and these deficiencies are avoided. Moving on to pantothenic acid, vitamin B5. It's part of coenzyme A needed for energy production, found in, again, lots of animal sources, salmon, beef, liver, eggs, also fresh vegetables for any vegetarians, in particular lacto-ovo vegan type individuals who would avoid even the eggs that we've talked about as a good source of a lot of these vitamins. So this one is present in fresh vegetables. However, if not enough is being taken in by the diet, deficiency can result in fatigue, slowed growth, cramps, and anemia. So again, like all of these vitamins, very important to be getting sufficient amounts either through diet or through supplements. Moving on to vitamin B6, pyridoxine and pyridoxal, which are two forms of that vitamin B6. They're converted to the coenzyme pyridoxal phosphate, PLP, and that's, again, typical dietary sources would be meat, liver, fish, nuts, and spinach in particular for a vegetable. Here again, deficiency, like many of these B vitamins, can lead to dermatitis, fatigue, and anemia. And there we have its structure down at the bottom. So we see it's a heterocycle, a nitrogen, as a member of that 6-membered ring, aromatic type ring with the alternating double single bonds. We've also got some hydroxyl groups there as well. Okay, moving on, we've got folic acid, or folate, and it consists of pyrimidine, paraminobenzoic acid, and glutamate. It forms the coenzyme THF, which is used in the transfer of methyl groups and involved in the synthesis of nucleic acids. So that being that it is involved in synthesis of nucleic acids, it's particularly important for pregnant females. Folic acid, of course, has been associated with neural tube defects if not enough is taken in the diet of pregnant women in those important early weeks. So the March of Dimes has been one of several groups that's been good about publicizing that, but certainly anyone who has any suspicion of being pregnant would want to be taking a pregnancy multivitamin and certainly making sure they're getting sufficient folic acid. So it has an RDA of 400 micrograms per day, so that's recommended daily allowance, so that's each day, and pregnant females should be taking probably double that amount to be safe. Deficiencies here would be abnormal red blood cells, anemia, poor growth, and then as I mentioned, some birth defects are associated with insufficient levels for pregnant mothers. And we have cobalamin, vitamin B12, rounding out the B vitamins here. This one is a coenzyme for enzymes that transfer methyl groups. Like many of these, it's found in liver, beef, kidney, fish, milk. As I mentioned, the lacto-ovo individuals should be careful to get sufficient amount from supplementation because they're likely not getting sufficient amounts from their diet. And deficiencies here would be associated with things like pernicious anemia, nerve damage, and malformed red blood cells. So in particular, this one tends to present pretty severely in terms of deficiencies, so wouldn't want to mess around with not getting enough vitamin B12 from the diet. Certainly safer to take a supplement, especially as I've mentioned with these B vitamins. They're water soluble. You really can't overdose. That's not a challenge. Certainly someone will overconsume something to a level that's unsafe, but if you're taking the amounts that are the recommended daily allowance, which is ordinarily what the supplements would have, then you shouldn't be concerned with the B vitamins about any type of overdose situation. Back to our good friend ascorbic acid, vitamin C, that I mentioned first when dealing with the water-soluble vitamins. It is required in collagen synthesis and involved in the healing of wounds. It's found in a number of fruits and veggies, so blueberries, citrus fruits, strawberries, tomatoes for your fruit sources, as well as green leafy vegetables. And then finally, deficiencies here. We already mentioned scurvy, weakened connective tissue, slow healing wounds, and anemia. So this is one that certainly you want to make sure you're getting enough through either diet or supplementation, because those deficiencies can be pretty severe and certainly nothing that we should be enduring in modern society, where we have ready access to both the foods and the supplement sources of vitamin C. Okay, and rounding out our water solubles, we have biotin here, which is a coenzyme for enzymes that transfer carboxyl groups. It's found in liver, yeast, nuts, and eggs. Deficiencies, again, like many of the B vitamins, we'd have dermatitis. This time we also see loss of hair along with fatigue and anemia, which we saw before for the Bs. Technically this is vitamin H, although it's much more commonly known by the name biotin. So it's not a B vitamin, even though it starts with a B, it's technically vitamin H, and you can see its structure there. We've got some nitrogens as part of one 5-membered ring, and then a sulfur as part of a fused 5-membered ring, and then finally we've got a carboxylic acid group at the very end of that chain coming off of the sulfur-containing 5-ring. So there we have it, what it is, what it does, and hopefully whether through diet or supplements you're getting enough of this important vitamin. Moving on to our fat-soluble vitamins, we have vitamins A, D, E, and K, and as their name suggests, these are soluble in lipids, but not in aqueous solution. So they're different from the water solubles that we've been discussing. One of the big differences is that they are stored in the body and not eliminated readily like the water solubles. So a real concern here is taking in too much of these fat solubles because your body does store them, and you really don't need the levels that you might be able to get by supplements. So it's much more important when concerning the fat-soluble vitamins that you're taking in between diet and supplements, if any, you're taking in reasonable amounts. They are important in aspects like vision, bone formation, vitamin E is an antioxidant, and you've also got blood clotting function. So they're very important, just like the B vitamins, but they are more dangerous in terms of potential for overdose because they do get stored in the body. And so we see here table 20.11 gives us some function sources, recommended daily allowance, and deficiency syndromes, but we'll be looking at these just like the water solubles one by one. Okay, so retinol, or vitamin A, is needed for retinol, which is used in vision. It's also involved in synthesis of RNAs. It has a recommended daily allowance of 800 micrograms, and deficiencies here could include symptoms like night blindness, immune system repression, and slowed growth. And so vitamin A can be synthesized from beta-carotene. So we see a lot of beta-carotene sources there. The beta-carotene, fortunately, you can't really overdose on, although if you eat a lot of it or you take large amounts through supplementation, it can give an orange color to the skin if you've really taken too much. But the beta-carotene form, fortunately, doesn't have the complications of taking the active form, the retinol form, which you could overdose on large amounts because it is stored in the liver in fat-soluble storage. Moving on to our next fat-soluble, cholecalciferol, or vitamin D, which is much easier to say, and it's actually D3 is the active form. It's synthesized in skin exposed to sunlight. So this one we don't necessarily have to get through the diet or from supplements, but if you're in the Northeast, like we are in the Binghamton area, wintertime in particular, there's not a whole lot of sunlight, and certainly wintertime in the Northeast, we don't typically have much skin exposed to that sunlight in those cold months. So it's probably necessary in those circumstances to take some vitamin D supplements. They regulate the absorption of phosphorus and calcium during bone growth, and oftentimes if you take a calcium supplement, it likely has vitamin D in it. Milk is typically has vitamin D added to it in the United States, and that's because of the vitamin D3's importance in phosphorus and calcium during bone growth. There's an RDA of 5 to 10 micrograms. Again, certain populations may need more, particularly the elderly or pregnant females, because deficiency could include weakened bones, and so those are populations where you don't want to run that risk. But the other aspect of vitamin D is it's the one that you can overdose on the easiest. So the therapeutic amount, that recommended daily allowance, is only, the amount for overdose could be just 2 or 3 times that on a regular basis, could cause problems with toxicity. So you have to be very careful with these fat solubles, in particular with vitamin D. If we look at its structure, notice, and I didn't point it out in the structure of vitamin A, but the same thing holds. We have an OH group, a hydroxyl group, and then a lot of hydrocarbon. And so that's why these are fat soluble, because the nonpolar hydrocarbon end of things is the majority of the molecule. That polar OH group is not enough to give overall polarity to a molecule of that size. Tocopherol, vitamin E, is an antioxidant in cells. It's actually often used in foods as an additive to prevent oxidation. So you may see that either as just tocopherol or mixed tocopherols, because as we see, you do have at least one chiral carbon there, the one that's bonded to the oxygen, not the fused aromatic ring side, but the other side of that oxygen in the 6 ring. The carbon that oxygen bonds to is a chiral carbon, so you can have D and L tocopherol. So oftentimes for the use as an antioxidant in foods to preserve them as a preservative for freshness, they'll use both forms. Oftentimes the supplement will be just the necessary form. Okay, it's found in whole grains and vegetables. It has an RDA of 15 milligrams, and deficiencies include hemolysis and anemia as side effects. So it is important that you do get enough of that through either diet or supplements, but again, being a fat soluble, you don't want to overdo it, because if you're taking way too much, more than the recommended amount, then you could run the risk of toxicity from overdose of this fat soluble vitamin. Okay, and I know you guys waited a long time for it, and here it is, our last vitamin for discussion, Menaquinon, or vitamin K, as it's much more commonly known. It's needed for the synthesis of zymogens for blood clotting. It has an RDA of 90 to 120 micrograms, and deficiencies are prolonged bleeding time and bruising. So this vitamin K is very important in that clotting. I believe that K is from the German for coagulation, because of its involvement there. This is one that, again, we see the problems with deficiencies, but if you're a person who's taking something for bleeding, clotting itself, you want to be careful about vitamin K. It might not interact so favorably. So Coumadin or warfarin, a blood thinner that's commonly prescribed to people, especially elderly people, those individuals have to watch their vitamin K intake. And vitamin K, it's not here on the slide, but it's typically present in green leafy vegetables. And so you have to be careful that you're not getting too much from your diet, especially if you're on one of those anticoagulation therapies like Coumadin or warfarin, as it's also known. Okay, so hopefully it was worth the wait. I know a lot of people have a lot of interest in those vitamins because there's something that are marketed to the public, right? There's not a whole lot of firm scientific information about it. If you've ever read those supplement bottles, a lot of times there'll be statements made on there and then an asterisk to tell you that that statement has not been evaluated by the Food and Drug Administration. So people have a number of misconceptions about the vitamins, and in particular, you have to be careful about those fat-soluble vitamins because you can get doses that are dangerous there. The water-soluble, you can waste a lot of money if you're taking high doses, but fortunately, you can't do too much damage most of the time because they will be excreted pretty easily. So let's see how well you've understood this long-awaited vitamin lecture with a learning check. In this particular learning check, you're going to identify each of the following as either a water-soluble vitamin or a fat-soluble vitamin. So go ahead and for letters A, B, C, D, and E, make those determinations. Stop the video here while you do so and start back up when you're ready to check your work. Good luck. Okay, so hopefully that wasn't too bad. Hopefully you were able to make the same assignments you see up on the screen there. So folic acid is one of our B vitamins, so it's a water soluble. Retinol, or vitamin A, is the first fat soluble that we discussed. Vitamin C is another water soluble. Vitamin E is another fat soluble. And niacin, again, one of our B vitamins, so that's a water soluble. And this mainly goes along with memorizing the names of the B vitamins and the names of the other substances like biotins and other water soluble. Then you had vitamin K as another fat soluble. In addition to vitamin E is the only other one that doesn't appear here, or the other B vitamins. But if you look at the structures, hopefully you have no trouble identifying them. As we said, the water solubles tend to have lots of polar functional groups, whereas the fat solubles tend to have very little in the way of polar functional groups, maybe a hydroxyl group here or there, but mostly lots of hydrocarbon components to them. So if you were confronted with the structures, you could use that, but with the names, it's really just a matter of memorization. Okay, and for our last learning check to end not only this chapter lecture, but the entire chapter 20, we have the task of identifying these vitamins associated with the particular description in the A, B, C, D, E below. So go ahead and for 1, 2, 3, 4, 5, pair them with A, B, C, D, E as appropriate. Stop the video while you make those assignments and start it back up when you're ready to check your work. Good luck. Okay, so looking down below, collagen formation, hopefully you recalled that that was ascorbic acid, vitamin C, that was important for that particular function. For B, a part of the coenzymes FAD and FMN, that was number 1, riboflavin, or vitamin B2. For C, absorption of phosphorus and calcium in bone, that was our good friend vitamin D, D3 specifically, and that's why it's often added to milk and other dairy products to help with the absorption of the phosphorus and calcium in those foods. For D, vision, that was our friend vitamin A. And finally, E, blood clotting, was vitamin K. So hopefully you already committed those functions to memory and paired them with the vitamins. If not, if you found that this was a difficult task because you haven't had time to commit them to memory, again, it's unfortunately just memorization. You can reach out to me for help. I'll try to give you some tips there, but it's mainly mainly just sitting with those vitamins and memorizing what their functions and classifications as either water soluble or fat soluble, as we saw in the previous learning check, what those are. So hopefully that's going well for you, or maybe you've already come into the course with that knowledge. If that's not the case, please do find some time to pair those vitamin names and functions together, and we will see you in the next and final chapter.